Hi everyone, today I'll be doing Codeforces Round 1000. I barely do any contests now, and I'm doing this one only because it's the special number. Segment. Oh, oh, I see. This is a minus B, yeah, B minus A task. No? What? That's correct, right? Is my thing broken? Uh, my extension might be broken. I'm not really sure. Let's just keep going. So you can choose sequence and reverse it, and then minimize some segment. Huh, that's pretty interesting actually. I think it's hard, does it not? No? Wait. So this is wrong. Am I stupid? Oh, wait, I'm dumb. I see, I see. Okay. Silly. Yeah, max connected components. Is this not just choose the ones with the max degree? The one. Like, let me just try. Times 10. Mm, no, it's not. Hmm. Oh, I think I see. Okay. I need to account that link. So that would increase it by 1 minute. Wow, okay. I don't see how to do this immediately. Okay, so they say remove 1 and 5. So I remove 5, the number of components increases by hmm? Oh, I think I see. Okay. So it's maximum of 2, but if they're next to each other, then it doesn't count. Let's use C++. Mm, okay, so rest of is let's find deck. Great, so we can erase that. That will actually 25. Rest I plus J is print 2 and still find J, and then again. Really? Oh, subtract 1 here, maybe, I think. Okay, submit that. Alright, is it submitting? I'm gonna submit it manually. Oh, I've already submitted it. Okay, I see. Cool. So I can, let me go back to this problem. Um, choose a subsequence and reverse it. This is so like, I really don't see how it works. Can I always just get the smallest couple elements? But it doesn't seem possible. But I don't think there's any counter examples here. Have you seen these counter examples? It looks like you can always just get the smallest, like arctic L plus one ones, but I don't see why that's correct. I guess I have to submit it. Who cares if I get wrong answer anyway, right? I don't understand why this is correct. If it is correct. I don't see anything else. Yeah, I don't think this is correct, but I'm just going to submit it anyway. Yeah, okay. I don't know how to do that. Huh. Yeah, it's wrong, which is, I thought it was wrong, but I don't know what the solution is. Oh, so they're all on two lines. Okay. So you need to choose two from one side and one from the other. And the error is just always the difference between those two. I think you would always choose like two big ones here and then take off one from that side. Yeah, that makes sense to me. The Kmax, okay, I can work out Kmax very easily. And then I think I can solve this, but I don't want to. I think you would only ever choose like stuff which is in the range and either everything else is to the left or to the right. I don't think you would ever do both. I think that's one observation. Yeah, so I think I do know how to solve this actually. Yeah, I think I know how to solve it. Find fx, x sort y sort of x. That returns of y up to add plus one as it return min f a r and like f of a from like L take one onwards. I print. Yeah, something that. Okay, let's go problem D. Yeah, so like you would repeatedly choose like the two extreme ends and then some point on the other side. Um, and you can that's greedily just the sum of these points minus some of these points. Yeah, that's easy. Okay. This might be scuffed. I'm just gonna try to bash my way through this problem. So we have sort of split. So that's A and this is B. So these are the number of pairs. While okay, so K max we'll say is the max of like n plus m divided by 3 and like it's not the max, it's the min. Like n and m or something like this, I think it's correct. Okay, so um max. So x, like x equals the two from A, like or like one from B, and like y is the other way around. And it's like a number of those. Okay, so So yeah, we need to satisfy a couple properties. It's just like math that I don't want to deal with is the problem. Actually, I don't, oh, this is my wrong tab. Okay, so we need to let me work out the math. So we need 2x plus y less than equal to m, and we also need 2y plus x less than equal to m. Um, so let's say like y is less, let's do what without first of all, y is less than equal to, and take 2x, and so 2n take 3x is less than equal to m, and x is less than equal to m take 2 times n divided by 3. Oh no, that was 2n take m divided by 3, I think. Is that correct? Take 2n take. I don't. I'm not. Okay, I'm not actually convinced. This is. I don't think it's correct. My algebra might be wrong here. Okay, what's wrong with my algebra? Maybe it isn't wrong, but it looks wrong to me. Okay, like if m is equal to 2, m is equal to 5, and then x is equal to, I don't know what, y equals 0. That satisfies it. But it doesn't satisfy this, so my algebra is wrong. The 2n. Oh, wait, this, okay, never mind. Hmm. There's just too much algebra to work through that I kind of can't be bothered. Maybe I can get away with not doing algebra. Hmm. So it's the opposite of that, and then so a one minus x, and then option B, same but with y, a plus 1, b. No, I think this is wrong. Oh no, I don't think so. What? Really? There's no way this is correct in like one go, right? Really? This is correct. Huh. Okay, this is kind of weird, greedy. So, your rooted tree, it's a good pair if they're not ancestors of each other, and not if they exist. Okay, so how many non-degenerate triangles are there in general for side lengths U and B? Okay, still going. So if it's like U and sorry, if it's, let's say it's A and B, the two, if this is A and this is B, then the min it can be is B take A plus 1, and the max it can be is B plus A minus 1, I think. And so it looks like there's just like two A options, maybe 2A plus 1. Oh no, 2A take 1, I think. Does that work? I think it looks correct to me. Let me test it on some examples. Yeah, that was correct to me. So I think it's twice the smaller one minus, so it's twice min of this minus 1 is the number of positive values of x. Um, is it AC? Yeah, I did. Okay. This is not a great contest. Um, actually, I don't know how my ranking is so high right now. I think it's because I solved D. So, okay, we need the sum of all things. Oh, that doesn't seem so bad, actually. I feel like you can just do some sort of small to large merging thing. Yeah, it always seems like you can do some small to large merging. Actually, maybe not. Maybe not. I take it back. I take it back. And actually, maybe you can do a small to large merging. Yeah, I think you can, honestly. But I think that gives me a log squared solution. I think that would TLE. Oh no, I don't even need small to large learning, do I? That would just be a DFS. Oh, is it maybe it's a implicit seg tree actually. Yeah, it might be honestly. Maybe I'm gonna read F1 and F2 just in case they're easier. But I think I know how to solve this actually. How many balanced bracket sequences are there given different nesting things? This is just like the Catalan numbers, and then we have different we split into different levels. Yeah, this doesn't seem so bad. Brackets. Is another way to match end proofs. Yeah, it's just this. So I just need to pre-calculate some factorials. And then I actually think I can do this with a treep. Very funnily. I'm gonna go for the easy version first. Um, yeah. So we want to do like in math. Um, so here I've up to 600,000. Okay. And here I'm gonna go vector vector in speeds of okay, so so Catalan 10, 10. here we will need 9824353, and we return um multiply. We want to multiply math dot factorial 2 by n, math dot inverse of s1, and math dot inverse of n. I think. So first we print. Oh, and Catalan. Actually, I'm just going to pre-calculate this. Five, 2 and 42. Okay, that's not what I expected. Oh, that's because of this. Okay, that's fine. That's because I didn't read in the full input. So here we go. Inverse Catalan. Do I have a power? So while okay, so for ambient size plus plus, so if find vi dot size, if vij is equal to L, vij is equal to I to j. Okay, so if x, then we've found the sequence. So I want to res inverse Catalan of vi dot size. Okay, so I want to v dot push resize v dot size plus 2. So actually, just v dot push back. Now v dot push back for is k plus plus. I read it back. Push back. VIK. Read it back. Okay. After this, I want to print. So here I should print. And like this. And then like, okay. So like one of these ones gives me like some sort of error. Is it here? No. Here? No. It's here then? Okay, it's in here. Oh, index R just never got seen. Oh wait, never mind. It should be, never mind, I'm being dumb. This should be here. Okay, let me just print out the sequences I'm getting and see what's wrong. Yeah, okay. VI hi. I'm so confused because okay, this should probably be n times 2 then. My bad, my bad. That's not what I expected. Okay. So now my math is just wrong. Ah, I see it. I think I see the issue. These should be divided by 2. Okay. Submit this. Because I believe for pretest 1, like for F1 to F2, all I need to do is optimize this, and I think I can just do it with a treep. Oh wait, do I even need a treep? Or can I just use like a DSC? Or like a link cut kind of structure? Yeah, I might actually be able to get away with a link cut tree. Okay, so that was AC. How's my standing? 21. Not the best, but it's okay. Yeah, I actually what I really need is just like to like all I really need to maintain is like either a tree or a link cut tree. I think I'm gonna go for link cut, honestly. I think it's easier to use. I think it's sufficient in this case. So I'm gonna go here, LCT, and then here I want to have like a next, and like a previous. Like what I really need is like, this is kind of, it's basically like a doubly linked list. It's a doubly linked list, but I need to maintain like the sizes of everything. Uh, uh, Maybe I'll use before. Okay. So now we have like a LCT. So link cut LCT. Is this one in next? I don't remember. I think it is. 7 times 2. Okay. LCT dot set. What is set to? Dot update. Value I with value 1. If I is less than n times 2. LCT dot like link I and not plus 1. And I don't need this v anymore. So we want to go like LCT dot. This would be LCT dot subtree. I think subtree of like L and L. Okay, so here if L has like a previous node, all like this has like a next node. LCT. So we want to cut. Yeah, so if before L we want to cut before L and L. If next L we want to cut next L and L as well. And same for R. This, yeah. So if they're both like nodes, then I should join them together. Oh, seconds. Okay, so I'm gonna do if y x, then if w or x and x, then we want LCT dot link w and x together, and then its node is max of them. So like LCT dot subtree node and node. Then I want to say if y is not equal to to R, I want to say node, the next node of z is 0, and here I want to say y and y. So that got close, but not quite. Not .lca dot link. And here I would also want to set the next node y to be x and the previous node of x to be w. Some more edge cases actually. I want to set next, so let's do fx is 0 here. Close again, but not quite. Yeah, the error is not in the maths, the error is in the link cut tree right now. I just need to like really go through these details and like try to work out exactly what's happening. So I cut those out before L next. Yeah, so those two nodes, we set them to 0, and then if they both exist, then we link them together. Yeah, we should link them together. And otherwise, And yeah, this is another one. This is the internal node. And we should I might just like do some debug things. Yeah, link. And here I'll say cut. Yeah, let's just do some debugging. Okay, so I'm gonna investigate. So we link these together. Yes. Now 1 and 6 is a bracket pair. Cut. Oh, we can actually just do this. So why am I cutting 1 with 1? So I see here we have cut 1, 1. Why would I cut 1 with 1 after? So is it here? Is it next L, which is wrong? Yeah, so here we have next 1 is 1, which is not correct. Oh, I plus 1. Is that correct? So do those links. Okay, that passed. I'm just gonna submit this. It might be right, it might be wrong. Not sure yet. Okay, so that's in the queue. Now I need to go think about problem E, which I basically already figured out kind of how to approach, which is just like yeah, some sort of ordered statistic tree, and that kind of maintains like the depths being distance from root to root to each node. Um, because we want to work out when things are smaller, so we should kind of put that into a set, and we can kind of do some maths. Oh wait, I think maybe not. I didn't say ordered statistic tree. I wanted like an implicit segment tree. Runtime error. That's not what I expect. Runtime error, really? 600,005, 600,005. That should be big enough, right? Yeah, I think so. So why would I get 300,005, right? Oh, should oh, wait, doing so no, I do reset next and before correctly, right? Oh, fine. Let's do fine. Zero. That might be it. I think that is an error. Submit again. Running on pretest 3. Okay, I made it past. That might be it. Hmm. Well, that's good signs for F at least. No, I really need to think about this. I think I have a log squared is the thing. I'm pretty sure this is log squared. I just don't think log squared will pass. I'm a bit hesitant to go for it. I'm going to try to find like an n log n. Okay, that looks good to me. It might pencil time. Okay, so that passed. Yeah, that's nice. Okay, so we might just go for the log squared. I am still okay, I might just think a little bit more still. Hmm. And this is kind of annoying to think about. Oh well, what to do? Hmm. It's, I guess like this. Just so yeah, here I'm just gonna go with implicit. This is my implicit segment tree template. So strict S, we're gonna say have total dist, and we're gonna have, I guess, just num. Yeah. So it's gonna have a dot total. Yeah. Okay, so here, like, so I both have like a seg tree here, and I also have like a dist here, a dist is equal to d. Okay, I don't think I need this, and exception is equal to, yeah, I want to make a new seg tree with bounds from, let's say, like 0 up to like n+1 or something. It's v dot set. Yeah, so here at the end, I want to go stv dot set. At the position of this depth, I want to add dn1 or something. Okay, so here I'm going to do small to large merging. So if dist u dot size is greater than dist v dot size, now we can kind of swap dist u and dist v. I also kind of want to swap those two, but I might need like another one, like a label. Label. and div2 dot pushback x. I don't want to actually add it back here. I need to add it back here. Into this segment tree. That's dot kind of query. No, dot product. X plus 1. Up current with like something like this. Okay, so st label b dot product from 0 up to say x. Some depth equals total dist minus I guess like the depth d rest dot num and then answer. Also like answer plus is equal to times some depths minus like rest dot num. And the number of remaining ones is this like v dot size minus rest dot number, and the answer class is equal to 1 times like 2 by take d minus 1. Yeah, that kind of looks right to me actually. I want to focus on you in this case. Ah, wait. Okay. That shouldn't be inside. Really? There's no way that's already correct. But I'm just gonna submit it. I don't have much time, but I'm like, how on earth would that be like correct so soon? I feel like this has to be incorrect, but I'm obviously I hope not. Huh. I think it might TLE though. This is my prediction. Because it's log squared, I think that might be the incorrect complexity. There's always a chance that it passes through. And like it looks like it's correct. I'm just not whether sure it's I keep opening up my my university homework instead of my VS Code. Huh. This contest was not my best, I'll say, but I am happy. Like I had a terrible like normally I'm fast at the easy problems and struggle with the harder ones. And today it seems almost the opposite. I think I was able to tackle the harder ones, but I did really badly at the first few. Like problem A, I saw I had wrong answer in my local IDE, but I couldn't actually see where it said that. Like I couldn't see what was the mismatch. This is kind of insane that it's passing. I didn't think it would. I don't know how many pretests there are though. It might still fail. Surely there can't be that many left, right? I'm just going to look at standings a bit. Yeah, it's a whole bunch of people. There's my friend's standings. It's still going. Don't TLE, don't TLE. The problem is these sort of. Oh, does this contest has sys tests? It does have sys tests, which means I'm not like it could be hacked or it could fail, like FST. Oh, pretests pass. Nice. 2 second. Oh, that's pretty very close to the time limit though, 1952 milliseconds. I might want to resubmit this just because it's so close to the time limit that there's a very good chance this would FST. Mm, I'm just gonna make some. Yeah, I'm gonna make some. So we're gonna say the update is like a. Oh, and then I don't need this. I can just do this. I'm making like constant optimizations essentially because I think it's gonna TLE. Uh, What's the Cactal PDF? I'm just going to spam a pragma as well. I don't really know what it does, but usually seems to work. Let me download this. Okay. Where is it? Okay. I don't know whether this will be good or not, but I'm just gonna chuck it in here anyway. And yeah, we're gonna go resubmit this. Because otherwise I think it will TLE. I will lose points for resubmitting, but almost certainly this would FST because it's so close to the time limit. 1202 milliseconds was the time limit on this problem. 3 seconds, so that should be okay. Yeah. Hopefully this doesn't use nearly as much time. Okay. While that goes, I'll just briefly touch on some solutions because while I'm waiting, I might as well go through some stuff. So problem A, so any two consecutive numbers are coprime. So x and x plus 1 are coprime, which means the answer is almost like a coprime. For a segment to be coprime minimal, almost certainly it has to be like two consecutive numbers like x and x plus 1. And so the answer is actually just r minus l, because that's the number of consecutive pairs in this range. There's one edge case though, which is that the segment 1, l equals 1, r equals 1 is also coprime. And that's kind of the one exception. So yeah, there's a special case. I got caught out. I could not spot the difference in my IDE, which is why I submitted like a wrong answer on pretest 1. Okay, it's still going. Problem B. So the observation here is like so each index is either before L inside the segment's range or after R. And it's pretty easy to see that you would never need to have you would never need to have you would never choose an index which is less than L and an index which is greater than R, because they're just going to swap positions with each other. And so you might just as well have chosen the subsequence that doesn't contain either of those two indexes. Essentially, you either choose indexes at most R or you choose indexes at least L. So in my code here, that's what I do. You either go indexes at most R or indexes at least L. Okay, this is much better for time. I'm more satisfied with that, so I think I'll stop optimizing there. And let's, for example, say we only choose indexes at most R. Well, what are we going to do? It turns out we can actually just choose the R, like this Rtech L plus 1 elements, which are going to end up in my final segment. And it turns out I can just choose the smallest of them. And in this case, it's not too hard to see why, because like there's elements like before L, there's like in my range like L to R, and this after R. And we've already shown that either you only choose indexes from here or you choose indexes from there. And this is kind of symmetrical. So we consider the case where we choose indexes from here. Essentially, as long as you choose like if there are elements in this bit which are smaller than the elements in this bit, we can just choose the elements which are smaller and the elements which are bigger. And once we reverse them, it'll be exactly correct. And we'll end up with all of the smallest elements in this whole prefix. All of those smallest elements will end up in here. So we can actually just kind of choose the smallest article L plus 1 ones. Hopefully that makes sense. This is actually a really nice problem and kind of a bit tricky. Like, I didn't see it for a long time. Okay, this problem, so sorry I didn't explain too much while I was actually solving, but I was trying to think about that. Yeah, you can essentially like just imagine deleting one. Just imagine we had to perform this operation once instead of twice. What would we do? Well, it turns out that we start with one connected component, and when we select a vertex and delete it, the number of connected components will increase by its degree subtract 1. Why? Because like if you, I think I had this before. If in like my graph editor, for example, if I copy this in, like for example, if I delete this 5, then the 7, the 6, and the 4, its neighbors, will become in their own, they will be in different connected components. So previously they were in the same connected component, and now they'll be in different connected components. So we have three extra connected components, but since we delete the 5 as well, we only have +2 connected components. So essentially what this problem just wants you to do is find the two nodes with the biggest degree, and because choosing the two nodes with the biggest degree will give you the most connected components. There's only one caveat, which is when you choose if you choose the two nodes are neighbors of each other, by the time you delete the first node, you will actually decrease the degree of the second node by 1. And so the answer for this problem is either you pick two nodes which are not adjacent to each other and you sum their degrees and subtract 1, or you pick two nodes which are next to each other and you sum their degrees and subtract 2. And if you take the maximum over all pairs, that's the answer. So my code just does this in a kind of dumb way. I just calculate the degrees of every node and chuck them into a multiset. Then when I just iterate over all nodes to be deleted first, so I pretend I delete it, and I loop through each neighbor, and either I do what I said, I'm going to delete this neighbor, and I'm going to take the degrees and subtract 2, or otherwise I'm just going to delete it from the multiset, and then whatever's left in the multiset are the nodes which are not neighbors, so I can just choose the largest degree, sum them, and subtract 1. Okay, so problem D. Oh, this problem is like a huge amount of work. Like I got kind of lucky that it kind of just worked first try. But essentially like if you just consider the area of any triangle, I wish that would stop moving, but if you consider the area of any triangle, like imagine it's this point, and that point, its area is actually just the length of the base, because the perpendicular height is always 2, and the area of a triangle is half the perpendicular height times the base. So it's really just the base. And like, imagine I just wanted to take one triangle. What would I do, right? So either I'm going to make the base be this leftmost extreme point and the rightmost extreme point on one line, or I'm going to do the leftmost extreme point and the rightmost extreme point on the other line, right? And imagine I had two triangles. I could do something similar. I could greedily take the largest base, and then for my second one, I will consider like the second point and the second point here, and like this first point and this last point here. So if there were enough points, I could actually just greedily do this. And it's not that hard to see why. Like, for example, if I wanted to remove exactly two triangles and I want to choose them with like both their base on this 0 line, y equals 0 line, it doesn't matter whether I put this point and this point with this point and that point, or I do the outer ones and the inner ones, because they're actually going to give me the same sum of base lengths. Like the base lengths will be the sum of these two coordinates minus the sum of these two coordinates. So in a sense, this problem just wants you to greedily consider taking like the outermost points on either line and then kind of deleting them and then rinse and repeat that. So there are a lot of caveats to this. So first of all, what's the maximum number of triangles? Well, you can't have more than n triangles because every triangle needs at least 1 point from this top line or from the bottom line. And similarly, you need at least 1 point from the top line, so that bounds it by m. And of course, the sum of the points divided by 3 is also a bound on the number of triangles, and each triangle takes 3 points. And it's fairly easy to show that this is the maximum, this is exactly the number of triangles you can make. And this is the main idea of the code. It's exactly what I said before. So option A is I choose 2 triangles. I choose 2 points from the bottom line and 1 triangle from and 1 point from the top line. And that gives me a value which is equal to like the difference between these coordinates. Or I do the same. I choose 2 points from the top line and 1 point from the bottom line. There's only like and then I just choose the best one. So like in my variables here, x is the number of times I choose 2 points from the bottom line and 1 point from the top line, and y is the number of times I choose 1 point from the bottom line and 2 points from the top line, and current is the total sum of areas that I have so far. Now, the reason for this code is because there are some edge cases, of course. So the thing is, like, imagine, for example, that there was like 2 points on the top line. Like, so like the top line has like 2 points, and like the bottom line has I don't know, 4 points. And let's say, for example, let's say that the optimal, like my first triangle, like takes 2 points from the top and 1 point from the bottom. The problem is I can't actually choose my second triangle currently because there are no more points on the top line. And this is a problem because it is actually possible to take 2 triangles, but they both have to be oriented with 2 points in the bottom line and 1 point in the top line. The problem is sometimes my choices from the past prevent me from actually being able to take the number of triangles which I need. And so in this case, I do one sort of conversion step. So for example, if I run out of points on the top line, what I actually do is I take one triangle which has 2 points on the top line and 1 point on the bottom line, and I instead switch it so it has 1 point from the top line and 2 points on the bottom line. So I'm changing which type of triangle I'm taking by 1. So if I do the change, I'm going to change it such that it has 1 point on the top and 2 points on the bottom. And now my top line, I would have used 1 point. Like used 1 point. And the bottom one, I'll have 2 points. And then that allows me to take another triangle. So this bit is just really conversion. Like if I run out of points on the top line, I'm just going to retroactively change one of my triangles to be the other way, to have two points from the top line and 1 from the bottom. And same for the other direction. If this also gets 4, I just flip it the other way around. And that's kind of it. Like, this is not very rigorous of why it's correct, but I think with some thinking, you might be able to convince yourself it's correct. So this problem E, this problem E, like, I kind of just bashed it. Like, I'm not sure whether this is the best solution or not, but okay. Like, let's say, for example, that, so we have these 2 quantities here. Let's say this is A, and this bottom quantity is B. Like, how many integer values x are there such that they exist in a non-degenerate triangle? Well, such an x has to satisfy a plus x is greater than b, and this rearranges just to say x is greater than, like, because they're integers, I can actually more precisely say greater than or equal to b plus 1. And so I actually have x greater than or equal to b take a plus 1. And similarly, I also have a plus b less than, a plus b greater than x. And once again, because this x is an integer, I can kind of really do this. And this rearranges to x is less than or equal to a plus b take 1. And so I know x is in this range, like from between like b take, the b take a plus 1 and like a plus b take 1. And the number of, and like this range has size like 2a take 1. So like, yeah. So essentially, the number of possible values of x is really just twice the minimum of these 2 numbers, subtract 1. Okay, so this is actually like all we really need. So ignore everything here in this in this DSU. So I'm basically just doing a DFS, but okay, so V is the current node, P is the parent, and D is the depth, depth being the distance from the root. And this is just the normal DFS stuff. Make sure if it's not equal to the parent, it must be a child, so we call DFS from the child. Ignore this for now. And what we could do, like something that's very nice, sorry, another thing, dists will just store all of the distances in the subtree of V. And like distances, yeah, is what I said, distance from the root. So this V stores like kind of like it will store like the depth of all nodes in the subtree of V. And what we can do is like something naive we could do is like for each like once we've done a DFS from U, we can like iterate through all nodes. We can iterate through all distances V, but no, sorry, distances Z and like dists V, and then do answer plus is equal to like 2 times min x z minus 1. And then once I've done this, then I can add like all these new distances from this child into my dists vector. The reason why I do it like this is I don't want nodes in the subtree of V, which are both in the same child subtree of V. Not sure if that makes sense, but like in order for neither of them to be an ancestor of each other, these two nodes must be in like kind of different child subtrees. They can't be in the same child subtree because I don't want to consider it then. Because I want to consider it where these like in my current node, I know it's a bit confusing because I use V and U differently to how it's used in the statement, but essentially I'm saying in my DFS, I'm now considering what happens when I am the LCA, and I'm looping through all pairs of nodes, which LCA would be me. So for if X is in U's subtree, then for the LCA to be me, the other node cannot also be in U's subtree. And that's why I kind of add the dists later here. So we could do something like this. And all that really is left is to kind of speed this up. So there's kind of two cases. There's one case is when Z is less than X. When Z is less than X, what I really need is just the sum of, I just need this expression, which is the sum of all distances less than X. This is kind of weird here, but essentially, like we know that distance of like some node to like my current node, it's the depth of X minus depth of V. And so my segment tree will actually just contain these depth X values, and then I will subtract depth V myself later here. So D is the current depth of the node, and I'm kind of subtract it. So why do I have this segment tree? Well, this segment tree kind of stores two values. Total dist, which is like the sum of distance, like the sum of all like dist values in like the subtree. And then this is just like the number of nodes in the subtree. And I need this number of nodes so I can like correct this minus depth V for each node which is in this total. And this gives me the sum of these dist values. And so this answer kind of handles the case where Z is less than X, because my segment tree will just query the distances which are less than X and like do this offset calculation, and it will be 2 times like the sum of depths minus res.num, the number of nodes in the number of nodes in that we've found in this segment tree range. It's a bit confusing again, but if we want to sum over like the sum over 2 times like min, like 2 times val minus 1 is equal to like 2 times the sum of all val nodes minus kind of like the number of nodes in the sum. This is kind of why we subtract res.num here. The second case is when which is when X is less than or equal to Z. In this case, the min of these two terms is actually equal to X. So once again, we offset it by depth V, so we actually get the distance. And how many nodes does this apply to? it applies to all of the nodes in dists V which aren't in this segment tree range. So it's all other nodes. And that's kind of it. The only thing is when we want to merge, like if we want to consider a U, we kind of do the small to large merging trick. So if dist U is greater than dist V, we should kind of swap them around. So we insert like the fewest number of elements. And this is a pretty common trick. I will just assume you know about it. Label U and label V is just so I can swap my segment trees around more easily. And last thing is I use an implicit segment tree because I need the segment tree complexity to be proportional to the number of to the number of nodes, like proportional to like the number of terms in the segment tree, but not like the size of the segment tree. I need it to be kind of small. That's why I use like an implicit segment tree. Hopefully that makes sense. I know it's a bit confusing. This set is not really a set. I had to constantly optimize it. This is really kind of an update. Yeah, that's about it for E. Like, I don't think I can explain this much better. Next, let's look at F1. This one is actually, like, F is surprisingly simple, to be honest. So we'll look at F1, because F2 isn't really much different to F1. So first of all, the Catalan numbers, you might have seen me Wikipedia this. It's kind of just a very famous pattern, like sequence of numbers, and it has this formula, but this Cn is also just the number of ways to balance, like the number of ways to nest n pairs of balance brackets. So it's kind of exactly what we want. So for example, the very first number here is always just going to be the nth Catalan number because that's the number of way to balance like n pairs of balance brackets, like nest them. So I just have this math struct which pre-calculates the Catalan numbers and their inverses. Yeah, so essentially, like, imagine we have like unknowns, like this is the example we have, and imagine we're told that like this 3 and this 6 are a pair. Well, how many ways are there to balance it now? Like the whole sequence? It's the number of ways to nest brackets to fit this 2 space. Plus, if we kind of concatenate this prefix and this suffix together to make like a group of 4, we can also, it's also just the number of ways to nest this group of 4. Because these are like kind of on the same level. So in essence, like, we just have a lot of operations where we have like a big sequence of unknowns, and then we magically find out that like 2 of these nodes are like pairs. And when we find that something is a pair like this, we just we actually just want to count like the Catalan number for the number of ways to put brackets in here, plus the Catalan number for like how to put brackets in like this prefix and suffix combined. So that's all I do here. So this vector v kind of just maintains these sequences which are like connected to each other. And I just loop through these sequences until I find that one that contains both L and R. And then here I just make a new sequence which kind of just concatenates that prefix and suffix, and a new sequence which is kind of what's between L and R. And I make these 2 sequences. All I do is like I'm kind of deleting this segment like that it used to be in, so I multiply by the inverse, which is essentially just dividing by the big Catalan number and then multiplying the 2 new Catalan numbers for the new sequences I made. And that's literally it. So this is n squared, and to go to F2, all you need to do is optimize this. So all we need to do is kind of maintain like the splitting and concatenation of sequences. Like I just need to maintain like a bunch of segments, and I just need to like cut segments up and glue them back together. And you can do this in multiple ways. Like you can use a treep, but here I've just overkilled it and I just use my link cut tree template because, you know, it's like a forest, and this allows me to get the sizes of stuff pretty easily. But this code is kind of exactly the same. I just maintain it like a doubly linked list. So for each node, I maintain which node comes after it and which node is before it. Like when I find ln_r, I just cut all of the edges to its neighbors, like of ln_r, because I'm going to delete nodes ln_r. Then here I kind of link the prefix and the suffix together, and then it's kind of same as before. I consider the Catalan numbers for like the two new sequences which I make, and that's it. So I think F2 is not super interesting. There's only 2 minutes of competition left. Let's see how I went. Not on the first page. That's unfortunate. Well, I did get 28th place overall, assuming that I don't get FST. So I'll keep you updated, I guess. And yeah, thank you so much for watching. It's been a very long time since I've done any contest, so I think this is a pretty good result for me. All right, bye.